Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So this is the E221. So this would be the continuation of our um, first major subject, which is the E211. Okay. So last in our E211, we are dealing with uh, we deal with those kind of circuit that applied, or the source that is used to apply is a DC. Okay, so we also deal with the method, and how does it uh, simplify when it comes to a certain circuit that is complicated in form. Okay, um, and at the same time, we also introduce some examples on how to deal with that. Okay, so now we will go to AC circuit. Okay. And at the same time also, no, before we proceed to this one, I have also discussed in our previous subject. I have already also discussed um, the function and operation of a capacitor and inductors when it comes to a a steady state na DC circuit. Okay? So ano yung magiging kuan niya, magiging equivalent circuit niya. So yung sa capacitor kay magiging short, pag pag na naging steady na yun siya, so magiging open circuited na yun siya, and for inductor naman is magiging short circuited na yun siya. So I have also discussed that one. So right now, we will be discussing about the AC circuit, no? Particularly, we will be discussing about how does capacitor and inductors um, deal with when it comes to a source, when it comes to when the source is an AC, okay, instead of DC. Okay, so so if we take a look at this one, we have here a capacitor that has a voltage across it and the current through it. Okay, so and for inductor naman, no, we have, as you can see here, meron tayong this is again a capacitor, no. So we use an AC circuit. If you can see this one, if you can see this type of source here, no, na may ganitong parang sinusoidal na sign, so this is actually an AC source, no, instead of DC source. Take note of that. So once again, last meeting, in our last subject, previous subject, we just deal with those kind of source that is DC lang. So hindi sila AC. Okay, or they are not alternating. Okay, so um, so now we also, from our previous discussion or from our previous subject, we also learned that the voltage across the capacitor is just equal to charge, no, divided by the epsilon sub O, and the area area or cross-sectional area of the plate of the capacitor that is being used. Okay, then if we substitute that one, no, with this voltage across the plates, so we have now here the total uh, total or the overall formula for the voltage across the capacitors. Okay, so yan siya. Now, since we know that I is equals to dt over dt, okay, so we already know this one. No? We know that the current is the derivative of charge across a certain um, component, whether it is an inductor or capacitor or resistor. Okay, so it is a time derivative of q. So by substituting the value of q, okay, solving for q here, ito yun siya, okay, ito, solve for q, so substitute that one here, and we can now have this one. Therefore, the current across the capacitor is C is equals to the current across the capacitor is equals to C dV over dt. Okay, and overall, no, we can now have that by comparing this one here, itong C dito, itong C dito at saka itong A over D, we can now conclude that C is equals to epsilon A over D. And of course, we have for current I is equals to C dV over dt. Okay? So these are just some of the derivation on how to deal with the capacitor when it comes to uh, dealing with an AC, but we will not be AC source, but we will not be having our discussion on that. Okay, so now, assuming that the source, the source here, is as a function of cosine, so it means that it is purely sinusoidal. Okay, so as you can see here, cosine of omega t. So substituting that one, okay, this v of t here, substituting that one here sa nakuha natin na current for the capacitor, which is equal to c dv over dt. Okay, so substituting that one here, so it means that we have to derive this v of t here. We have to take the derivative of its. So we have here now the derivative of a cosine of omega t is equals to negative sine of omega t times the derivative inside the argument. So we have here omega. So all in all, we have for I of t, it is equals to c, negative c a omega sine of omega of t. Okay? Or by taking or by neglecting the effect of negative sign here, so we can have the shift of the argument here, which is shift of pi over 2 or 90 degrees. Okay, so yan. So as you can see here, okay, so this is the if we take the graph of this voltage versus the current here, the voltage is actually um, has a higher value, no? And for the current naman that we have that just find out, we have here this one, okay? So it's purely sinusoidal for the current, and for the voltage is cosinusoidal, okay? So yan siya. Now, in dealing with the AC circuit, it is very important to know that we have first to convert uh, that capacitor to its equivalent um, reactance, no? So it's because um, um, uh, actually, it's not its capacitor itself, okay, to have its effect in a certain AC circuit. So what important is its equivalent reactance, no? So that is actually suggested by this equation. Okay, for you to be able to find the reactance of a certain capacitor, so you will need this one. So we have 1 over c omega, where omega is the um, angular frequency, and usually it is equal to um, 2 pi omega. No, 2 pi multiplied by the frequency, or 2 pi multiplied by the period. Okay, so be familiar with that one. So this equation here is always used when it comes to solving a circuit. Okay, when it comes to solving a circuit that involves an AC circuit. Okay, take note of that. So, um, so ito yung pinaka behavior ng capacitor. So capacitors do like to pass a current at low frequency, and capacitor like to pass a current at high frequency. Okay? So yan yung pinaka um, summary ng function ng capacitor. Okay? So this is on how to deal with the parallel connection of capacitor. So as you can see here, when we have a parallel connection of capacitor, diba, what we need is the current, no? The current here is the sum of the current across them, through them. Okay? So that is suggested by this equation here. Using KCL, or Kirchhoff's current law, we can now find out that the current here is the sum of all the current here, no individual current here. So we have now this one. Okay, then by using the expression of the current across the capacitor that we have just derived here, okay, this one, um, we have now this one, okay, I sub k is equals to c sub k dv over dt, where I sub k is suggested by this one. Okay, then substitute that one, so we can now have this one. Okay, or factor out the dv over dt, since they have just the same voltage. Okay, so see, because they are in parallel connection, so we have now this one. So therefore, for the parallel capacitor, for the parallel capacitor, for you to be able to find its equivalent capacitor, no, so you just have to add them. Okay, so we have here C equivalent is equals to the parallel connection of that capacitor. Okay, then for the series capacitor naman, it is opposite. So we'll just have to have this one. Okay, so actually it is opposite with the resistor that we have already done in our previous topics. Okay, in our first major subject. Okay, so actually, no, there you had I will let you to read this one, this remaining topics here, the energy, the power, all in all, that is how to have the um, the effect, of an AC source, no, when it comes to a capacitor. Okay, so just read that. So meron tayong example dito. So ito yung summary natin. So paki-read din to siya. So we have also here an example. So please read this one. Okay, definite example for you to be able to fully understand those kinds of connection. Okay, so we have different examples here. Okay, so please refer to this one. So dito tayo sa inductor. Okay, so for the inductor naman, no, so these are just how inductors originated. So please read that one. But I will go on through this equation here. Okay, so for the voltage across the inductor, it is equals to L di over dt. So if you remember for that capacitor, no, so uh, we have also the same expression with this one, di ba? If you remember, for that capacitor kasi, yung current through it is equals to C dV over dt. So dito naman sa voltage across the inductor kay L di over dt. So parang nabaliktad, no? Doon kay ang expression that is equal to the derivative is yung current. Dito naman ang expression that is equal to the derivative is yung voltage natin. Okay, so baliktad yung capacitor and inductor, take note. Okay, so once again, this is just on how to derive the formula in dealing with the inductor when it comes to AC circuit, but I will not let you to on that one. So dito tayo. Okay, so for if we have an inductor that has a source of a sinusoidal, so we have this one, I of t equals to I sub o cosine of omega t, and by using that one here, itong equation na to rito, L di over dt, i-substitute natin itong expression for the source current, so we can now have this one. Now, so if we take the graph, no, graph of that current and the voltage, for the current is it's a purely cosinusoidal, and for the current is purely sinusoidal. So this is also opposite with what we have just learned from our previous topics, na yung sa capacitor kay ang voltage niya is pa ganito, and then yung current niya is pa ganito. Okay, so opposite with this one, kasi dito ang current is cosinusoidal, and then for the voltage is sinusoidal. Okay, pero all in all, they have just the same effect, no? So they can all used in an application where there will be an AC source, okay, or alternating current source na nagsusupply sa kanila. Okay, so if you have now a parallel connection of capacitor, okay, so ganun pa rin, the derivation is using KCL. We have the current here is equal to the current, equal to the sum of the current individually here sa branches na to. Okay, then after that, substitute the expression for the I, okay, for the current. Then we have now this one, factor out lang natin yung ating integral na part. Okay, this one, so we let this one. So therefore, for the parallel connection of the inductor, we have now L equivalent is equals 1 over L1 plus 1 over L2 plus 1 over L3 up to 1 over Ln. Okay, for the inductor that is connected in series naman, in series we have this one. So what we'll do is we just have to add the equivalent, or we just have to add the individual inductances. Okay, so this is quite different with our previous derivation on how to combine the parallel and series connection of the capacitor, no? Kasi sa capacitor, if we have a parallel connection of capacitor, what we'll do is we just have to add them, okay, individually. And for the series capacitor, we will just to perform like this operation. Pero dito sa inductor, pag parallel yung connection natin, ganito yung way na on how to combine them. Pero pag series, we will just have to add them. So it's quite opposite with our previous na na-discuss for capacitor. Okay, so once again, this is for the energy. So please get to know about that one. Okay, so we have also here the real inductor na function. So please read this one. And this is the summary. And we also have here the problem. Okay, so kindly answer that as well. Okay, so once again, if you have any question regarding this one, so you may ask it to me right away para hindi tayo um, uh, or para tuloy-tuloy yung learnings natin. Okay, so next meeting we will be discussing about the polyphase circuit na. So what is very important here actually kay yung equivalent reactance. By the way, ba yung sa capacitor kay na-introduce ko sa inyo yung equivalent reactance niya, no? By using this equation. Wait lang, ha? So using this equation, sana ba yun? Using this equation, sana. Ito. So, for the capacitor, its equivalent reactance is suggested by this equation. So, we have 1 over C omega. Okay? 1 over C omega. So, for inductor kasi, okay, for inductor, so we have, for inductor, we have, ang equivalent reactance niya is just a multiplication of, um, omega and C. Omega and L. Okay? For the capacitor kay, XC is equals 1 over C omega. For the inductor is XL is equals to omega L. Okay? So once again, where omega is just a multiplication of 2 pi, a multiplication of 2 pi multiplied by the frequency. Okay? So wait lang. So let me wait, huh? So we have here, so for, di ba, for X, for kuan, wait lang. For inductor, XL is equals to um, omega L. Okay? Where L is the inductor and omega is equals to 2 pi F. Or this is also equal to 2 pi over the period T. Okay, so yan. So, ito yung equivalent reactance natin. So, we will use this one in order to deal with the circuit that has an AC source, that has an AC source, and what do you mean by AC? So, that is actually an alternating source. Okay, so AC source, and that involves this different components, capacitor and inductor. Okay, so once again, if you have any question regarding this one, so please ask it to me right away. So that's all. Assalamualaikum warahmatullahi wabarakatuh.